Hello, everyone. I'm Tomasz Tarczynski. I'm a system architect at Gigaset, and I want to talk today about configuration management landscape for Kubernetes. So what I would like to talk about, there are four parts, like first to introduce configuration management as a topic, then talk only a little bit about Kubernetes, what it brings to this space of config management. Then a little bit about declarative approach to application management. And the last part would be the tools landscape itself. So the config management as a topic. There is this great quote which goes, of all the problems we have confronted, the ones over which the most brain power, ink, and code have been spilled are related to config management. And it comes from this paper, Borg, Omega, and Kubernetes, from engineers at Google who basically described their experience running the complex systems and cluster orchestrators for something like over 2 decades at Google. So as you can see, they perceive configuration management as a very difficult problem to solve. What they talk about is that they've tried something like a few dozens different solutions to this problem, and they still don't consider this to be a solved problem. So something like they tried a lot of different approaches. And what this config management means to me. So to me, it's mostly about infrastructure as code. So it would mean I would like to write some kind of code, then keep it in version control, like in Git repository, and treat this Git repository as a single source of truth about my whole environment or all the systems. And traditionally, there were some typical tools for that, like Puppet, Chef, Ansible, that we've used for config management. Just a very brief look into history of this area. So the first tool here was CF Engine, and it was 1993 by Mark Burgess. And then we've got Puppet, Chef, Ansible later on. But what you can see here, that is already almost 3 decades of experience in this area. So I would say it's also a lot of wisdom to build upon when we move to next generations of how we manage our complex systems. Okay, so to me, this traditional config management was mostly about Puppet, and only a very brief introduction to few characteristics that were the most important to me. So Puppet, it always gave me a declarative approach to configuration. So I can describe the desired state, and then I've got the tool that takes care of making system to converge to this state. The resources automation, it's also something important. So we've got types and providers. For example, I want to have a new user in the system. So there is a provider for that, and I can use just a common API to define those different things that should happen in my systems. It gave me a DSL, a domain-specific language. So it's a very simple and constrained language, and it's targeted strictly to defining configuration. It gives way for templating my configs. So if I need a config file, I can use a special templating language. Here in Puppet, it was ERB, so embedded Ruby templates. Modules, it's a great way for sharing my code, my solutions for automating stuff. So I can package my Puppet code into modules and share it either publicly in Puppet Forge or privately within my organization. And the last one is code data separation. So in Puppet, there is hierarchy for that, and it lets me keep my code generic and separate from parameters. So I can keep those parameters in a separate hierarchy and it let me reuse the code that I write. Yeah, so that would be it for just briefly introducing Puppet and what are those important characteristics. And now I would like to dive into Kubernetes and to talk only briefly what it changes in this area. So the most important thing about Kubernetes to me here would be that we've got with Kubernetes this control plane that provides us with a declarative API. So we can very easily declare the desired state of the whole system. And then there is the control plane that would constantly make sure that the actual state of the system would always convert to the desired state. So yeah, I would say it's mainly about this API that is declarative. And how do we declare those things, this system configuration in Kubernetes? So if I want to define a simplest possible application, it would be something like this. So I want an nginx to be deployed. I want 2 replicas of nginx, and I want a service to expose it to the world via network. So as you can see, to define the simplest possible thing, I've already needed some 30 lines of YAML. And actually, this example is way oversimplified, because if you follow some best practices, you would probably go into above 100 lines of YAML for a very simple application. So it seems quite a lot of YAML here. So I've tried to count how much YAML actually we deal with. So I've taken just one environment, the real environment that we work with at Gigaset, if I've counted the number of different things. So resource types. In such one cluster, we've got 50 standard resource types and another 50 of custom resource definitions that we've added ourselves. Then how many objects do we have? So in this particular cluster, we've defined about 800 of objects, but then there are internal objects for cluster purposes, cluster internal purposes, and there are above 5,000 of those. And then how much lines of YAML actually we have got? So there are something like 100,000 lines that we've defined configuring those clusters. And then together with all those internal objects, there is 500,000 lines of YAML. So based on that, I would say this is really a lot of YAML to manage. And actually, this is just a one cluster. And typically, you would probably work with several of those. So it's safe to say that we typically work with something like millions lines of YAML with Kubernetes. So there was this config management conference, and there was a great Ignite talk by Bob Walker. He asked, are we all YAML engineers now? And then he described Kubernetes as Kubernetes is basically, in his words, a system for YAML generating YAML. As you've seen in my example, like, yeah, we provide some YAML and then system generates itself a lot more. And the answer that Bob gave was, of course, yes, we are YAML engineers now. That's for sure. Okay, and the next part is to introduce this idea of declarative application management. I would base a few ideas here on the great article written by Bryan Grant. It is Declarative Application Management in Kubernetes. And he basically proposed some basic foundation ideas of how to work with configuration in Kubernetes. So the central idea that he proposed was to have actually not a single tool for managing configuration, but rather to have some tool set of composable tools that you can connect and mix together. So it should be mainly about manipulating configuration data, working with those declarative data models. So Kubernetes provides us with those declarative APIs. And what Bryan talks in this article is to have tools that let you generate, transform, and then apply this data to the Kubernetes cluster. And actually, also what he is opposed to is actually not to use or to treat configuration as code. So rather than writing some code for configuring systems, he talks about this idea of treating configuration just as data. So it would mean like leveraging this distinction that we've got in Kubernetes, like when we write code to automate something, it very often goes into controllers. So we've got those control loops inside the cluster that would constantly make sure that our actual state will converge to the desired state. But then we should actually be able to provide just data in those native Kubernetes API format to define what should happen inside the system. And then if we try to compare what I've talked a little bit about how it looked with Puppet to what happens when we introduce Kubernetes, it looks something like this. So I wanted some solution that is declarative. So in Kubernetes, we've already have this declarative API provided by the cluster. Then I wanted some way for automating resources. And in Kubernetes, it's typically already done by the Kubernetes controllers in the control plane. And then I wanted this code data separation method. And Kubernetes is also, I would say, already covered. Like we've got a declarative API for providing our config data, and then the code goes into controllers. And then there are those three areas, DSL, templates, and modules, that are actually not covered by Kubernetes itself. And this would be the area that I am interested in and would talk about in a minute, talking about different tools that can help us here. Yeah, so now after introducing the topic of config management and how I would say we should approach it, let's dive into the tools landscape itself. First, to just have some gauge of how big space is it. So this great spreadsheet is also done by Bryan Grant. So he put together a list of all known tools for managing configuration in Kubernetes. And actually, there are over 120 of those in this list. And the list is also constantly growing, and there are more and more tools appearing and being done. So you can see based on that actually this is a huge space. A lot is going on, a lot of changes, new ideas. And for sure, we can guess based on that it is in fact not a solved problem yet, as so many people are trying to build something new. Okay, now just a few words about different possible approaches to configuration. It's also based on this article from Bryan Grant. So the simplest possible approach is just to fork our configuration. So we've got some original config taken from, for example, from GitHub, from authors of some technology. And with fork method, we just copy and paste this config, make some changes to it, and we are done. It's not scaling well for sure, but it's the benefit is that's the simplest possible way. Then the next one is overlay patch approach. So with this one, we are able to have some basic generic config. And then what we do is that we prepare some diffs, some patches to it. So we want to have some kind of a diff to this configuration, apply this on the base config, and this should result with our desired config at the end. Parameterization, next possible approach is about having some kind of a template that we would define our desired config with only some aspects of it being parameterized. So we can then define different parameters, and when we apply this config, we can apply with some modification based on parameters that we provide. Yet another one is generation. Here we write some kind of code that would generate our YAML or JSON configuration, basically. And there could be different approach to that one as well. And the last two are two different approaches to what we use to program those things. So we can either go into the DSL approach, like using domain-specific language. So it would be a constraint language, especially built for managing configuration, only for that purpose. And the other one is to use general purpose languages, something that we are probably already familiar with, like maybe Python or something like TypeScript. And both of those have some pros and cons. Like people tend to say that the DSL approach tends to be actually a safer approach, like you won't shoot yourself in the feet, like it gives you limited possibilities, but also limited risks. And then GPL, general purpose languages, they've got a great ecosystems of tools for working with this code. So different people prefer different approaches here. Okay, so having those approaches, now let's take a look into some of those tools. So the list by Bryan Grant was a huge one, but I've chosen only a dozen of those tools and would only briefly introduce some that are most interesting to me, and also I would say the more popular tools. So first category, there are three tools that are the most popular among Kubernetes users. I've put also some gauge of popularity, the number of GitHub stars. Like, yeah, it could give us some idea how popular a tool is. So we've got JSONnet, Helm, and Customize. And starting with JSONnet. So it's the oldest of those three tools. It's originated at Google, and the idea here was to have actually a special data templating language. So it's a DSL approach. The language is based on JSON. So it is a superset of JSON. So it's JSON with some additional aspects. And the only purpose of this language is to basically generate JSON. The idea that was very strongly highlighted around JSONnet is to have something that is really hermetic and side effect free. It means that doesn't matter where you run your code, what is in the environment, what happens around, it should really always give you the same results. And this is not so easy with general purpose languages, but with this DSL, they worked to have it that way, to have it really, really hermetic. Then the next one is Helm, which is actually the most popular among all those tools that I've looked into. The approach that people have with Helm is basically to have something for templating YAML. It is based on Go template. It actually treats YAML just as a text file that many people brings as a disadvantage because it is not aware of YAML syntax, so it doesn't protect you from any kind of mistakes like syntax errors, anything like that. It gives you a way for packaging your configuration into charts. That's a great thing because if you configure a piece of technology, then you can package your config and later share those configs. So Helm also provides a way for really simple sharing of your configuration definition, so of your Helm charts. You can share them either publicly or privately in your private repos. And actually, Helm takes this approach of managing a few different aspects of configuration. So there was this templating engine, there is the mechanism for packaging into charts, and it also manages releasing those configs in Kubernetes cluster. So it will also help you managing the state of those configs inside the cluster. Then the next one is Kustomize. And Kustomize takes a different approach. It's template free and without any kind of DSL. So the approach here is just to use plain YAML. So actually it would work like you have some basic generic configuration and then you use this overlay approach. So you would provide only some diffs, some YAMLs telling what should change compared to the basic config, and Kustomize will help you compile those two into the resulting configuration. So basically, it's for customizing Kubernetes objects. What's also nice about Kustomize, it's built into kubectl. So actually, if you work with Kubernetes, you already have it available. So it's really, really easy to start with it and to just use it with kubectl. Okay, and now the next category. So the next category here are the GitOps tools. We've got two things here, FluxCD and ArgoCD. Those two are actually very similar in what they do and also quite similar in popularity. So the main idea about those GitOps tools is actually to put all your configuration, all your YAML into the Git repository, and then to keep the Kubernetes cluster constantly in sync with what you have defined in Git. So to make it happen, those tools use an operator inside the cluster that would constantly make sure that the cluster state would converge to what is defined in Git. And also what's interesting, both those tools, they integrate nicely with other tools in this area. So you can use both Helm and Customize with both of those tools. Argo CD also integrates well with JSONnet. And actually, this GitOps approach, so starting from the Git repository, it lets you integrate with pretty much any tool you choose. As long as you've got some tool that is capable of generating YAML and storing it with Git, then you can use the GitOps tools that would take it from there. Okay, and then yet another category. So some newer tools in this area, the Capitan, Tanka, and Kept. A bit less popular, but those were also quite interesting to me. So first is Capitan here. And Capitan is a very interesting approach. It consists of two main things, two main ideas. So first, there is a template engine, and you can actually choose among few of those. You can use JSONnet, Helm, or Jinja templates, or Cadet. And then there is inventory for providing parameters. So this is very similar to this Hiera approach with Puppet. So this inventory here is a YAML-based hierarchy of parameters, which lets you actually provide first some basic parameters and then maybe some overlays on top of that, or some more precise parameters for either different environments or different applications. Yeah. So you can manage really, really nicely all those parameters that you need. And then Capitan lets you compile your Kubernetes manifest based on templates and inventory, and then store those resulting YAMLs in Git. And you would, of course, use then some GitOps tools from there to apply those. Then next one is Tanka. Tanka came from Grafana Labs, is powered by JSONnet. So what it does is mostly about providing a special JSONnet library for Kubernetes, for defining Kubernetes objects. So those are things like having some simple function for defining typical things like that you do in Kubernetes. Like if you create deployment, most probably would need a service as well. So you can use one simple function for defining such set of objects. It was created as a replacement for JSONnet. So JSONnet was a very similar project done by Heptio, but later on it was discontinued. So that's why Grafana Labs came to build something very, very similar based on those JSONnet learnings. And what's interesting here, it also integrates very nicely. So you can use Tanka to also generate config based on Helm charts, or you can also integrate with this with Customize to customize your configs basically. And the third one here is Kept. So Kept is also originated at Google, and it has very, very strong opinion about this treating configuration as data. So it is heavily based on those ideas provided by Bryan Grant in his article. So it is very much about having different pieces of code that would work with configuration, and it would be for manipulating those configs. So Kept is capable of some sort of packaging of your configs, but it's actually a very, very simple one. So it lets you just fetch your configs from somewhere in Git, and then it would let you run different functions to work with those configs, those YAMLs. So you can have functions for generating config or to do different transformations to it, or for example, validate your configuration if it is like if it conforms some rules or some policy that you have. It actually integrates very well with a lot of different tools or ideas. There are ready-made integrations or functions to use Helm and customize together with Helm, with Capt, but actually you are able to use anything at all. Like if you just put some tool into a function that in Capt is just a container image, then you are able to chain those different tools together and make some number of transformation one after another. So it's, I would say, a new approach, but something quite interesting to me. And then yet another category, also quite new tools in this area, but both of those were quite interesting to me. So first is YTT, and YTT is yet another DSL. So it's a domain-specific language. It's, I would say, an approach quite similar to JSONnet. So it's a data definition language. The main difference here is that is based on YAML, not on JSON. So it extends JSON, it extends YAML by basically letting you program and programmatically define what you would like to see in your YAML. It's YAML structure aware, so that's great compared to Helm because it would always generate a valid YAML. Also, what's nice is that the YTT template, it is always also a valid YAML. This language is based on Starlark, so they used a Python-like language for adding this logic, like you probably would like to have some loops, some conditional stuff like that inside your config for generating it. And it also supports this patch overlay approach, something similar to customize. So you can basically use both. So you can be generating in a template-like way, or you can create some overlays for basic or generate configs. And then the second one here is Q. This is also a new language in this area, also originated at Google. It's like one of the engineers who working for a long time in the config management space area inside Google, who knew different approaches that they have to config management. So he had this opinion that actually it would require a totally new approach. And the language that he proposed is described as a data constraint language. So it's a very different approach to actually anything else we know in this area. It's built as a superset of JSON as well, but how you work with it is like you define your JSON config as a more and more concise definitions, like you provide more and more detailed constraints to your config. And actually, there are a few very interesting characteristics, like in this language, they don't distinct between the data itself and the data types. So you can use the same thing that you use for defining your data to actually validate your configuration. So you can also write very nice data validation code in it. And the main purpose of it is to have a nice way for reducing boilerplate. So in Kubernetes, when we've got those hundreds line for a single application, it would mean you can define earlier on anything that is typical for each and every application, and then you would put only those differences, what is specific for your app. So yeah, also something interesting, and I think they've got quite a bit of traction after Q. And now the last category that I would like to highlight, those are the infrastructure as code tools. So the idea here is like we've got tools specific for defining our infrastructure, like Terraform, and why not use those for defining what should we have inside Kubernetes clusters. So for managing configuration, we can use Terraform. With Terraform, we work with a DSL that is also JSON compatible. So it's HashiCorp configuration language. It lets us basically declaratively declare the call of our config that we need. And to use Terraform for Kubernetes, we need a provider. So provider that would encode how can we configure Kubernetes objects. And there are three most interesting providers that we can choose from. First is the stable Kubernetes provider that provides us basically the 34 core resource types in Kubernetes. When you use this one, you are basically constrained to those types that are already there in the provider. And then based on this limitation, there is the second provider by HashiCorp. It is Kubernetes Alpha that lets you basically define any resource type that you wish, and it also includes custom resource definitions. And yet another provider is Helm that lets you use basically Helm charts, and you can manage the releases of Helm charts and provide all those values to Helm releases using Terraform with this provider. The second tool here is Palumi. So it's a newer approach compared to Terraform, but it's in some ways similar. It's described as infrastructure as code SDK, so they provide you a software development kit. And what's different compared to Terraform, they let you use general purpose programming languages. So you can choose between things like Python or TypeScript. And yeah, the benefit here would be like you can use all the tooling used by programmers typically working with code and you can use the same for working with your configuration code or infrastructure code. What's also nice here about integration, so you can use Helm or customize together with Palumi, or you can just put plain YAML into it. This SDK is, it is compatible with all the Kubernetes objects and also supports CRDs. And the last one is CDK8. So this one is from AWS. So the very similar to approach to Palumi, I would say. So it's based on this cloud development kit by AWS, but this one is purpose built for Kubernetes, just for generating Kubernetes objects. And yeah, similar to Palumi, you would use general purpose language. It also lets you use Helm and also supports any kind of objects and CRD. So I would say this would be the list of tools that I would see like the most interesting. And to give you just some kind of summary and what I've talked about and what we can observe here. So I would say we can see some interesting patterns here. So between those most popular tools, we can see that there are the three most popular, like the JSON, Helm, and Customize. And then quite a lot of other tools, they typically integrate well with those. So actually Helm, which is the most popular tool from all those, it also integrates well with anything else. So each tool would support Helm for providing configuration. And actually, I think there is a good reason for that. That's because for any kind of technology that you would like to deploy to your Kubernetes cluster, you would most probably find a ready-made Helm chart for that, most often provided by the authors of the project that you would like to use. So I would say working with Kubernetes, you probably won't avoid using Helm anyway. And one more thing here is two different approaches to what to do with configs. So a lot of tools will let you just generate YAML and store those YAMLs in Git, and then use GitOps tools to take it from there. And the other approach is just to apply those configs straight to cluster. And at the end, the last thing, so there is the CNCF technology radar. So what they've done is a kind of survey. They've asked the CNCF end user community about what tools do they use and how they see those tools. And those users highlighted Helm and Flux as tools worth adopted. So they are worth adopting as people think that it is something well established and really, really stable to be used. And then the trial category is something people say it's worth trying and maybe experimenting with. And those are, here we've got Customize, and then JSONnet and Argo CD in the assess category. Something maybe worth taking a look into. There are also the detailed results from this survey. So if you are interested, you can see how people did respond. There are also some interesting parts, like you've got those gray areas, which is yet another category. So you've got adopt, trial, assess, and the last one is halt. And halt means people use this, but maybe see it as something a little bit outdated as they approach. So that's also interesting here. Okay, so here are all the materials from this talk. I will also share the slides if you would like to check any of those links. And that would be it from myself for today.
Thank you, Tomasz.
Thank you.
It was really a cool talk. I will let David take over for the questions. But yeah, if you guys have any questions for Tomasz, like yeah, either type them on the chat or feel free to unmute yourselves, or even start a discussion, whatever.
Yeah, thank you, Tomasz. Question from my side. Can you tell us, because at the beginning you mentioned you show a slide how many resources you have, how many YAMLs you have. Can you give us the estimate? How big was the cluster? Like how many nodes, how many pods?
Yeah.
Just rough estimate.
Nothing huge, just a small cluster, like below 10 nodes, and number of applications. I'm not sure, maybe like a few dozens, maybe, yeah, maybe
So
30 or so, yeah, pretty small.
Pretty standard cluster, I would say, yeah. Okay.
Yeah, and already, yeah, as much YAML there.
Yeah. Okay. Another thing, it was great basically to find all these tools reviewed, let's say. But I would love to find some opinion from your side, like which one you like personally, or for example, Terraform versus Palumi. What would you choose?
Yeah, it's really hard to give some recommendations here, so that's why I avoided it. But what I prefer, I can talk about. So basically, it as always, it really depends what you need. But to me, it was like when trying to choose tools best for our team, I've actually went for those that are the most popular. So for over 2 years already, we use Flux and Helm as our two tools of choice. And why we do that is, first, there is the biggest audience of, so the biggest number of users out there. So it's really easy to find help if we've got any kind of trouble with those tools.
Yeah.
Helm is great because all of the configs that are already there. So if I have some standard project that, I don't know, I would need an nginx ingress, or I would like to have Redis inside of my cluster, there is always already a Helm chart for that. So yeah, this is a big thing for Helm to me. And yeah, actually, we were using those for some time already, but I was really interested about all those other options. So at different conferences, we keep hearing about all the different tools. So I've went through basically tutorials for each of those just to give them a try. And I would say for today, most of the other options, I would see those like a bit too difficult to start with, considering the needs that we've got in our organization. So there are a few different teams working with those clusters, operations team, then some development teams. And what they say to me is that they really don't want to learn something new. Like working with Puppet was already too much for them. And then they don't want to learn JSONnet or anything like that. And that's why they say Helm is fine, because it's so simple to start with.
And if we have hypothetical situation that we have a company who just moving to the cloud, so just starting with the cloud from scratch, would you recommend some other tool then? Because like if they don't know any other tools anyway, yeah, they have to learn something new anyway. So would you pick something else than Helm, or would it be still Helm?
It depends. So as I said earlier, like I would say you cannot avoid using some Helm actually. So that's, yeah, I would say you would always have some to work a bit with Helm. But then, for example, if a company starts with cloud and they decide to go for Palumi, for example, just to use general purpose languages that they are already familiar with, then I would think that it could be a good idea to use Palumi both for your infrastructure and also for your configs inside of the cluster. It could be interesting.
Yeah. Okay, Great. We don't have any specific questions on the chat. If you still have some, feel free to write. Tomasz, I ask you just to enter the chat and ask any questions if there is so many. And yeah, thank you very much for the talk.
Thank you.